Okay, so for part A, actually I'll do part B. Part B, it says that y equals f of x minus 1 in parentheses and then minus 3. So I just want to kind of make it clear what you do. So for B, y is f of x, is it minus 1? Minus 3. Okay, that's supposed to say f of x minus 1 minus 3. It's a little messy, but I think you can tell. All right, so when we worked with the graphs the other day, the whole point of that is for you to figure out that if you do something just to x before you actually apply any sort of function operations, that has a horizontal slide effect. So what this means is the graph slides or translates or is shifted. All of those mean the same thing. To the right, 1 unit. So that whole red graph should go to the right by 1 unit, but it shouldn't change anything else about what it looks like at all. This is just like you scooted it over. Yeah.
Shouldn't it move to the left because it's minus 1?
You would think, but it doesn't. And if we had more time today, I would talk you through with a parabola. You can see really easily why it is. Short story is that it has more to do with the fact that x itself isn't changing. You're doing something to x and then applying function operations to that. And it's really more about how y changes than anything else. So we will do that exploration, but for now, so that you have this, so the first thing that happens if I do this particular part of the problem, I want to take this whole thing, and the easiest way to do it is to just take each of these points and write a new point that's the same thing, but just, I don't know why it's doing that, but just 1 unit over to the right, and then connect them, so that it should look like your graph is the same thing as what you had before. Then for the second part of the problem, the minus 3, that's on the outside of the function. This minus 3 has a vertical effect. So the minus 3 takes the blue and moves it down 3 units. So it's like you're taking this entire thing and removing and subtracting 3 from every single point so that it all just moves straight down 3 units. So this slides or translates or shifts the graph down 3. So when you subtract or add something to the entire function, it has a vertical effect, and it's exactly what it looks like. When you do something just to x before you apply function operations, it sort of has the opposite of what it looks like. All right, so you take these points now and you move them down 3 units. So this one might be kind of down here. This moves 1, 2, 3 kind of here. This one moves 1, 2, 3 kind of here. Whoops. I don't understand. Oh well. So that it looks like this and like this, and then 1, 2, 3 is here, like that. And the green graph is your final arrival point. Yeah.
Okay, so like, if it's the horizontal sliding thing, then it's the opposite of the sign, but if it's vertical, then it's not.
Yeah, you can think of it that way. All right, and you can convince yourself. Make a table of values. I mean, if you want Because we will do this when it takes a little bit longer than what we have to do it, but if you want to have an exploration that kind of gives you why it goes to the right instead of the left, look at y equals x squared, and then look at y equals x minus 1 squared. Make a table of values and see what's happening. I mean, either look at it in a calculator table or just physically by hand make a table of values and see what happens, and you can see why it is that it turns out that way. All right, probably this is something that I'll take care of on Friday.